This art truck in front of us broke down on the roadside because it carried too much load. Fortunately, it wasn't far from a repair shop, so the mechanic quickly arrived. With years of repair experience, the mechanic swiftly removed the engine oil pan and discovered that the crankshaft had broken. In our country, such a situation typically means replacing the crankshaft with a new one. However, in rural Pakistan, where parts are hard to find, the mechanic proposed the fastest and most cost-effective repair solution: removing the crankshaft for repair without taking out the entire engine. It had to be brought to the repair shop to fix the crankshaft. The repair shop lacked many things, but not second-hand crankshafts. The mechanic found a broken crankshaft with the exact specifications of the pile. Since two broken crankshafts needed to be joined to form a single crankshaft, the excess parts had to be cut off before the splicing could begin. The mechanic completed this process seamlessly, using a handsaw for the areas the lathe couldn't reach. After cutting, the mechanic used a lathe to smooth the splicing surfaces and create a bevel suitable for welding. Then, a drill bit was used to make the center holes for the splicing. Surprisingly, almost all these operations could be done with just one lathe. The same procedure was followed for the other end of the crankshaft. The mechanic carefully adjusted the coaxial alignment and began machining the splicing surface. Due to the length of the spindle, a proper interface was machined directly, with continuous measurements using calipers to ensure the spliced shaft met uniform dimensions. Finally, the two processed crankshafts were joined into one. The experienced mechanic achieved a perfect fit. After fine-tuning the position, welding and reinforcing the splice began. The pre-prepared bevel made welding smooth and efficient, completing the splice quickly. The crankshaft was placed back on the lathe. The mechanic adjusted the concentricity using a dial indicator. As the lathe spun quickly, the weld on the splice was machined smoothly to standard dimensions. However, the crankshaft's smoothness still didn't meet usage standards, so a unique tool was used to polish all the crank pins, giving the crankshaft a smooth and shiny appearance. After polishing, the crankshaft met the required precision and smoothness. A standard oil hole was then drilled, and the crankshaft was ready for installation back into the truck. To ensure the crankshaft's proper function, the mechanic thoroughly cleaned all disassembled parts and replaced the bearings. Under the mechanic's skilled hands, the reinstallation process went smoothly. With a test ignition, the long-lost roar of the engine came back to life. All the data showed normal, and the truck owner happily drove off. If the total score is 10 for this repair method, what would you give?